All right, factoring by grouping. Problem 3, factoring by grouping. What we're essentially going to do is we're going to pair up the front and we're going to pair up the back. Let's get some colors going on here. So I'll pair up the first two and I'll pair up the back two. And then we'll divide out the biggest thing that we can. Okay? So the largest thing I can divide out of the first two terms would just be a straight x squared. Okay? Because, I mean, there's no number to give here on the first one. So it's a 3 and a 1, so I can't divide anything up there. But the x's I can. So x cubed divided by x squared would just be x. And 3x squared divided by x squared would be what? 3. Very good. All right. And then I'm going to look at the second one and say, hey, what can I divide out of that one? Well, that one I can divide out of 7. They both have 7 to give. All right. And I'm actually going to take the negative with it, and I'll tell you why in a second. Okay? So we're going to divide it by negative 7. So negative 7x divided by negative 7 leaves what? X. Good. Negative 21 divided by negative 7 leaves a positive 3. Okay? Notice how these two binomials are the same. All right? They're both x plus 3, right? That is by design. All right? If they are not the same, something went wrong, you need to go back and do it again. So like if I'd have divided by a positive 7 instead, I'd have had a negative x and a negative 3. And these would not be the same. Okay? Since they're the same, I can divide one more time. I'll divide the whole thing. This is one thing times x plus 3, and something else times x plus 3. So I can divide that x plus 3 out. And I'm left with the coefficients of x plus 2, x squared, and minus 7. Okay? Basically, like this is one giant term. This is another giant term. We just divided out the x plus 3, and the coefficients are what was left over. Okay? So that is factoring by grouping. It's called that because we are literally grouping them together. All right? Now, ask this. Is that factored completely? No, it's not. He's like, I said that just because you asked it. And that's fine. That's a wise choice. All right, so this has an x squared minus 7 right there. So I'm going to drag the x plus 3 down. And I can factor that right side. Now, question. If it was an x squared minus 9, what would I put on the right side over here? 3. Because the square root of 9 is 3. Do you know what the square root of 7 is? Well, is it even? Is it an even number? No. So here's what I'm going to do. I'm going to say x plus the square root of 7 and x minus the square root of 7. And that's okay. All right? That is factored completely.
How do you get x squared minus 7?
Okay, the x squared minus 7 came from the two coefficients. These two formed that binomial. You follow me? And the x plus 3 were the other binomial. Okay? Good question. All right. If I lost you on this last step, I'm sorry. But how are we doing on getting to this one? Any questions on that?
I don't know what the first step.
How to do the first step? Basically all I did is I looked at this set right here and I said, what can I divide both of those terms by?
1.
Well, I can divide them both by 1, but that doesn't do anything. But I can divide it an x squared. So that's what I did. The second two, I can divide them both by a 7. And so that I got the same binomial, I divided it by negative 7. Okay? Here, let's do another one. Scroll up to letter C. Let's do another one. All right? Letter C. Same idea. Let's start off by grouping them together. Group the first two, group the second two. A z cubed. All right, what can I divide out of the first pair?
X squared.
A z to the third power. The first one has 4, the second one has 3. So I can divide out a z to the third power. Or a z cubed, however you want to say it. And divide them both by z cubed. Z to the fourth divided by z to the third would be what? Z. Z to the 1, which is z. There is an understood 1 there, we just don't write it. It would be z to the 1. Negative 2 z to the third divided by z to the third would be what? Well, it would be 2, but is it negative or positive? Negative 2. All right. Cool. So that's the first half. The back half. What can I divide out of that? I can divide 27 out of that. You're right. We're going for the biggest thing we can. Every so often we got to back it off to make sure we get the same pair. But we're going to go off for the biggest thing we can. Okay, so do you want a positive 27?
Negative.
Or do you want a negative?
Negative.
Negative. Good. We want to make sure we get the same signs as this one over here. So it's negative. So negative 27z divided by negative 27 is what? Z. Positive 54 divided by negative 27 would be negative 2. And my screen keeps moving on me. Being weird. All right? Let's see if I can slide that back up. All right. Any questions on that? Start to feel a little bit better? All right. Then what are your two binomials? What's one of them?
Z minus 2.
Z minus 2 is one of them. Okay. Good. And the other one is z to the third, or z cubed, minus 27. Cool. How are we doing with this far right here? Give me a 5 to 1. 5 I got this, 4 I'm okay, 3 and 2 I'm lost, 1 save me, I'm drowning. Okay. Look at that. So that is the process of factoring by grouping. All right? It is pretty easy. You just got to get used to the pattern. All right? Is it factored completely, though? No. Okay, which one can I factor more, the first one or the second one? Second one. What method would you use to factor it? I might ask you that. Difference of two cubes. Very good. It is a difference of cubes. So the cube root of z to the third is what? Z. The cube root of negative 27 is what? Well, let me ask you, forget the negative for a second. What's the cube root of 27?
3.
3. Is it going to be a positive 3 to get a negative 27 or a negative 3? Negative times a negative, that's positive, times negative again comes back into negative. You can think, just go like, okay, that's negative, positive, negative. We end up with a negative. That's fine. Si, senor. Yeah, and that little line is going to end up on the video. There we go. Whatever. All right, so remember, square the first one, multiply them together but flip it, square the last one. So square the z, what do you get? Z squared.
3z.
It would be a positive z, 3z, right? Because you got to flip it. What would the last one be? Positive 9. Very good. And that is factored completely. All right? All right. Now, to be honest with you, like the answers in your book, go for it. The answers in your book, some of the time, they're going to tell you to factor by grouping. Okay, that's fine, factor by grouping. But the answer in the back, I don't know if they stop here or if they stop it completely. I really don't know. All right, so just be wary of that if you're checking the answers in the back. All right, back up to letter D. I want you to try letter B. I'm sorry, B as in boy. Try letter B on your own. All right? Pair of front two, pair of back two, get as far as you can. Come on, Jonathan, go. 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 There we are. And let's put it on the board. There we go. Alright, so I have a number of people trying to do this by a difference of cubes, like we did letter C. Can you take the third root of these ones? No, so it's not the same pattern as we ended up on letter C. But this one it is. It's like this one. I can take the square root of both of those, the second root. Alright? So again, we're having more and more patterns that you're having to keep straight. Alright? So this one just breaks down to an x plus 3 and an x minus 3. Just like this one broke down to an x plus square root of 7, x minus the square root of 7. We just could take the square root of 9. So that's the only difference. Cool? Yeah, I want to do another one. Let's do the last one. All right. If you got it right, great. If you got it wrong, fix it. All right, do letter D.
So,
Do letter D.
I was
I was just talking about that literally just now. All right. So this is not a difference of cubes. This is a difference of squares. So what multiplies that but adds back up to 0? Does that make sense? And then you can figure yourself out what's going on.
So it's just.
Yep. 3 and 3, exactly.
on this one, would you just one?
Yeah. What was the plus or minus? Yeah, positive divided by negative is a negative. So it'd be a 9 minus 1. All right, I need to work it out on my own real fast. Sorry, give me a second. Sorry.
Plus one.
You're dividing out a negative 64, right?
Yeah.
So you would have to divide out, positive divided by negative is a negative.
That's negative.
Cubed minus 64.
I'm so pissed at Hunter.
What's up?
Can you scroll back up? Because I didn't get the last part of the last equation.
Give me a second. Actually, I wonder if I can do that. Let's do this. There we go. Freeze that. What's what? 190. 64 times 3. 64. You don't want the third root of 64, not 64 times 3. What times itself 3 times is 64? No. 4. Because 4 times 4 times 4 is 64.
So would it be z squared minus 64?
Well, z cubed minus 64. Here, let me just put it up there. All right.
Almost with him Saturday, so
You've got z cubed minus 64, right? The third root of 64 is 4. Because 4 times 4 is 16, times 4 one more times is 64. Does that make sense?
See, that's where you let me, because, okay, I got it right, like, I got it right.
Got this far?
Yeah, but you right.
Did it backwards.
Yeah, you put them on.
Oh, I put this one second and that one first. Who cares? I did that on purpose. All right? I did that on purpose because does it? Okay, let me ask you this: is 2 times 3 the same as 3 times 2? Yes. So x minus 2, x plus 3 is the same as x plus 3 and x minus 2. It's the same thing. It's okay? All right? It's the exact same thing. All right?
See, when I see it, I'm like, dang, I did it wrong.
I still did it
And then I'm like, wait a minute, no, I got it right. Good.
I got it right, bro.
Good, good, good.
So how do you do that?
I got it right, bro.
How did I do the end? You talking about, okay, so this one came from here and it just came along for the ride, right? This one, remember? This one's a difference of squares or a difference of cubes? Cubes. So I take the third root and I get that. Remember, square the first one. Multiply them, yeah, z times z is z squared. Multiply them together but flip the sign. So negative 4 times z is negative 4z, but we flip the sign. And then square it back. Negative 4 times negative 4 is positive 16. Straight up where they came from. All right, let's keep on rolling. Slide on down to the next problem real fast. They bring in the idea of synthetic division, which it's been a while since we did that, but you'll pick up on it real fast. Synthetic division is that thing where we had like 2, that's a 2, believe it or not. Like 1, 0, 9, negative 4. So that's a 1. 1 times 2 is 2. Added up, that's 2. 2 times 2 is 4. Added up, that's 13. 13 times 2 is 26. Minus 4 is 22. Think you kind of remember that at least a little bit?
Yeah.
That's what we're doing, but we're using it for a very specific purpose. Okay? So, problem 4, it says use synthetic division to determine if the binomial is a factor. Okay? So what they're trying to find out is this a factor of the polynomial they gave you? Okay? So what we're going to do, first things first, we got to know what we're dividing by. So set it equal to 0 and solve. So we're dividing by x equals what? Positive 2. Because you have to add the 2 to get it over, right? So this is what we're dividing by. All right, so we got 2. And then grab our coefficients. With that one's a 1, so we're going to grab 1, 2, and negative 4. Everybody cool so far? All right. You remember the first thing we're supposed to do with this? Drop the 1. Drop the 1. All right, so it's 1 times 2. So 1 times 2 is?
2.
Add them up and you get?
1.
4. 4 times 2 is?
8.
Add them up and you get?
4.
4. Good. Everybody cool still?
Yeah.
Here's how you tell. This right here. What I have just proven is that when x is 2, y is 4. So this equation has the point 2, 4. Is that a root? Is that a factor? Is that an x-intercept?
How'd you get that?
Is the point 2, 4 cross? Is that on the x-axis?
Oh, yeah.
Yeah. You sure?
Yeah.
What is the y value when we're on the x-axis?
4.
0.
Say that. It's 0, right? Exactly. So is this a root? Is this a 0?
No.
Therefore, this is not a factor. Okay? That is not a factor. What we're looking for is that 0? If it is, then yes, we have a root, because it would be at the point 2, 0. That's on the x-axis. All right? If it's not a 0, it's a legitimate point. It's just not on the x-axis. You follow me? So the answer is no. X minus 2 is not a factor. Okay? Let's try letter B. Letter B. First things first. If I set the x plus 5 equal to 0, I'm going to divide by x equals what? Negative 5. Good. Divide by 0. All right. So negative 5. And then what are your coefficients for this?
3, 15, negative 1, and 25.
Very, very close.
Negative.
What goes after the negative 1?
Oh, 0.
0. Good. That was a dirty, rotten trick. Everybody has fallen for it today. All right. Why is there a 0 there?
Because there's an x squared on the
Good. There's no x. We got the fourth, the third, the squared, the 1. The x has a 0 in front of it. That's why it's not written. So we got to put a 0 in the place mark. Okay. So here we go. Drop the 3. 3 times negative 5 is negative 15. Add them up. You get 0. 0 times negative 5. 0. Add them up. You get negative 1. Negative 1 times negative 5 is?
5.
Add them up, you get?
5.
Times negative 5, you get?
Negative 25.
Add them up, you get?
0.
0. So, that's your remainder. Is this a factor?
Yeah.
Yes. C. Because we have the point negative 5, 0. That is on the x-axis. All right? Cool? Does this make sense to everybody at least? Whether you're through or no? All right. Turn the page. Try letter D, as in dog, on your own. Yes, it's the bigger of the two. I just want to go straight to it, see if we can do it, and go on.
Which one?
All right. Letter D. Flip it over and do letter D. Yes, ma'am. No, he's out. Try letter D. All right, here we go. Is this a factor?
No.
My what? No.
You sure?
Yeah, it is. It is. It is.
It is. Let me ask you this. Did you put a negative 1 right here?
Yep.
Yeah. Wait.
No.
I did. I did.
I did.
I did.
Good. All right, a lot of people forget this today. I'll be honest with you on that one. All right, but otherwise, if you've got something other than 0, just check your math. All right, it's really tempting to go through this really quickly and then do something mentally dumb. I mean, just like 2 plus 4, oh, that's 9. You know,
I need it for 8th
you've seen me do this. You say you need me for 8th period?
I was talking to him.
Okay. Sorry. I'm like, what? That was random. All right, good. All right. Any questions on this? How are we doing? Give me 5 and 1. 5, I got this. 4, I'm okay. 3 in. 2, I'm lost. 1. Let me out of here.
How about a 6?
I got one person changed to a 1. Good. All right, here we go. All right, let's talk about how else we're going to use synthetic division. Problem 5. It says factor using synthetic division. Okay, we can use synthetic division to factor as well. Okay, because we can use it to pull out those roots. All right, and so here we go. We got an x minus 3. That is a legitimate factor. So what we're going to do, set it equal to 0. What are you going to divide by? Negative 3. Let me blow it up a little bit. And then bring down your coefficients, which are what? 1.
9, 26.
All right. Take a second. Run it through the paces real fast. Yes, it is a factor. Yes, you will get a 0 at the end. But it's what we do with it after the fact. Six times negative 3 is negative 18. That is correct. All right, how are we doing? Negative 0?
Yeah, we got 0.
All right, sweet. So here's what we're going to do with this. The remainder tells us what the other point is. If it's a 0, we can say, hey, this is my next equation over here to the left. That's your constant. This is your x. This would be your x squared. If I had another one, it would be my x cubed. The one to the left of that would be an x fourth if we had it. So I can write this out as x squared plus 6x plus 8. I simply divided out the factor x plus 3, and this is the remaining, this is the polynomial that's left over. Okay? And then factor that. So if I were to factor this, do I need to divide something out? Let me slide it up for everybody. Can I divide anything out?
Yeah, 2.
Out of this?
Oh, no.
Can you divide anything out?
No.
No, you can't. All right. Does it look suitable for grouping? Does it have the 4 terms in it to do certain? All right. So should we just pull up a parentheses and go with it? Yes. Here's what I mean. Can we just do this and do left goes to left, right goes to right?
Yeah.
Yes.
Yeah. What are 2 things that multiply to the left? X and x. 2 things that multiply the x squared. All right, what multiplies to the right? Multiplies with the 8. 4 and 2. All right. Can we rig them to go back up to a 6?
Yeah.
Yes.
Yeah. Are they positive, negative, or what? They're both positive. So our factors are x plus 4, x plus 2, and x plus 3. That was the original factor they gave us to us. If you look at the original problem, they gave us that one. All right? So this is factored completely. Cool. And that's factoring using synthetic division. All right? You're literally dividing out a term, and what's left over, you factor that further. All right? Technically, you are factoring out an x plus 3. All right, what's letter you factor further? All right, let's do letter B. Let's do that. All right, we're doing several of these because they come out differently. All right, they're all a little bit different in the way they come out. So here we go. First things first, if that's an x plus 3, what are we dividing by? Negative 3, very good. Negative 3. And what are your coefficients?
1, 3, 0, 3, 1.
Good. You've got the 0. All right. Divide real fast. All right. Should have gotten a 1, goes out to 0, times 0, 0, times 0, 0, and you're left with negative 1. Cool. Oh, you dropped your 0 in the middle. Because remember, this one doesn't have an x squared. So that's what that's for. So that's what happened. Huh?
I do need it, but
You do need it. Basically, what that would put is that
it's
you don't have this one because you didn't put this one in there. Does that make sense?
But I'm good on my polynomial.
If you know what you did wrong and you fix your polynomial, yeah, you're okay, but I wouldn't rely on that because this should be an x to the third minus 1.
Mr. Hunter, how you get the...
Because remember, this is your constant. That's your x to the 1, or x. This would be x to the 2. This would be x to the 3. And again, x to the 4 if you had it, and so on and so forth. Cool. So are we going to factor this one like the last one we did over here? What is it? What are we going to use? Can we take the square root of it? Okay, can you take the cube root of it? I know the 1 freaks people out. All right, so what is the third root of x to the third? Just x. Forget the negative for the second. What times itself 3 times is 1? 1. All right, is it negative to get to a negative or positive? Negative. A positive will never multiply to a negative, so it has to be negative. All right? And then, just let this up for y'all. Remember, it's square the front, multiply them together, flip it, square the back. So it's, what's your first one?
Square.
X squared. Your second one is an x. Is it positive or negative? It's positive. Remember, it's negative 1 times x, which is a negative x, but then we got to flip the sign. Right? And then what's the back one? Negative 1 times negative 1 is? Positive 1. And then we'll drag down, what was it, x plus 3? I can't see it on my board.
X plus 3.
Yeah. That's your third term. And no, yeah, that has an x squared, but no, it can't go any further. All right, because nothing multiplies to 1, but also adds to 1 at the same time. Cool. Nobody's having a right aneurysm? Almost. Nobody's got right nose or anything like that?
Almost.
All right.
So I have a question. Okay, so
Go for it.
I always forget. So it's square, multiply both, and then multiply by x. So
Well, think of it this way. You're always multiplying 2 things. All right? And you can take 2 fingers, put both of them on the first one. So I'm multiplying that one twice. And then I move 1 over, I multiply those together. And then I multiply those 2. All right, the difference is when I do these, I have to flip the sign. So it's like I'm slowly moving over. Does that make more sense? More of a visual way of thinking of it. All right, let's do one more and then we'll turn the page. The reason I want to do it is it turns out a little bit differently. So first things first. What are you dividing by? Positive 6. Good. He's like, I'm tired of multiplying by negatives. All right, what are your coefficients?
0. No, 3. 1.
1.
Negative 5. Negative 6. And 0.
Good. First person today to remember the constant. No one else today has remembered it. All right. Yes, the constant has to be up there. All right, so run it through its paces real fast. Well, the numbers come out a lot lower than you expect. It's kind of like 1, 0, 1, 1, 0, 0, 1. It's kind of like all the answers in your test being C. It's like, this can't be right. How are we confused? What's going on?
is it x squared plus?
Yeah, is it x squared plus x?
That's exactly right. This is your constant, this is your x, and that's your x squared. So it's x squared plus x. So the question becomes, well, what are we going to use to factor this one? To give you a hint, before you try any other method, what do you always try first? Which sometimes I'm bad about trying first too, I'll be honest with you. Divide. Can you divide anything out of these? An x. You can divide them by an x. So if I divide by x, what is left over? X plus 1. And I'll drag down the x minus 6 for good measure. And it's done. What's really, it's actually just kind of sad. You may have a test, something that goes up to an x to the 6th. I'm not saying you will, but it's possible. All right? And we'll work you up to that point. Don't worry about that. And we'll have students that can get through all of that and they'll do great. But they'll see this and they'll freak out. And all it is dividing something out. All right? It's okay. I get it, sort of. All right? All right? Any questions on this at all?
get the X minus 6?
How to get the x minus 6? It's that guy right there. Can we stop?
Yeah.
Never.
Oh, okay.
All right, one more. Turn the page. Wrong answer. All right. I know, right? Word problems, your favorite. All right, so here we go. During the first 5 seconds of a roller coaster ride, the function blah represents the height of a roller coaster after t number of seconds. All right, so we got height and time. Which one is time? Your x or your y axis?
X, yeah.
X. X is your time, Y is your height. Okay. The question, how long is the roller coaster at or below ground level? Okay. So what part of the graph are we looking for if we're looking for below level?
The height.
Well, this is time 0, so we don't need the part to the left, but do we want this area right here? Do we want this area right here?
The bottom right there.
The bottom curve. This is underground, right?
Yeah.
The bottom corner.
Alright, so that bottom little piece. So we want to know, what is the distance from this point to that point? Well, do we know this point? 2. It is right on it. Do we know this point? Well, look at it. Is it right on the 4? It's 4 point something. Alright, so we don't really know. Let me ask you this. Do you know another route on there? Another x-intercept? -1. Good. No, it is not part of the roller coaster ride, but it's part of the function. So we can use it to solve for the third. So here's what I'm going to do. Since I know these two factors, I'm going to divide two roots. I'm going to divide them out. And what's left will be that one. Here's what I mean. The 2, it crosses the x-axis right there at 2. Crosses the x-axis at -1. All right, so here we go. I'm going to start off, let's divide out the 2. So 2, and bring down your coefficients. 4, -21, +9, 34. And we will get 0 as a remainder because 2 is an actual x-intercept. All right, so drop the 4. What's 4 times 2? 8. It does look like a y. You making fun of my handwriting? Yes, it's okay to say yes. 8 minus 21 is what?
-19.
13. -13 times 2 is -26. Good. +9 would be negative. -17 times 2 is negative. Good. So that's a 0. All right. I'm going to do it again with what's left. So I'm going to ignore this column because that's not part of what's left. So just do it again. Drop the 4. What's 4 times -1? -4 and -13 add up to negative. Times -1 is positive 17, which is a 0. So if that's your remainder, it would be 4x minus 17. That is a factor.
4x.
And to solve for a factor, you just set it equal to 0. Cool. Notice how we've taken factors and set them equal to 0 to see? So move the 17 over, it becomes what? Positive. And then what do you have to do to get to x? Divide by 4. So x is 17 over 4. What's 17 divided by 4? What's 16 divided by 4? 4.25. So it goes from 4 to 4.25. How long is the roller coaster underground?
4.25.
2.25 seconds. How long is it underground? Because it's between the 2 and the 4.25. This is when it's under the ground. That's the original question. All right. Stop it. All right.